clear? Alright, so that's a code I construct for exercise 2. So if you check, let's check from the first one. So we have to first declare the side. The side, because here we have 6 terms. I'll put it on 1.
Okay. 已经快要翻白眼
You
了。
guys are forcing me. Every time you take the phone, I was like, please, let's just. So we have the term, so we declare the size. So if you check the data, we will have the side term should contain from 1 to 6, right? But interesting one is like, what's the second side? Because we are working on a 2-dimensional plane. Whenever we have a coordinate, we have 2 coordinates for one location, right? So let's say I call side coordinate. So basically, in that coordinate, I have 2 elements. The first one is called A, and second one is called B. So basically, whenever I had like a coordinate, it's a variable, and it should contain 2 elements. And then the next one, parameter. So we have the parameter. We have the coordinate, the location coordinate of 6 terms, and we know them. We display them. And the location, why we have 2 subscripts? Because the first subscript means the location is for each term from 1 to 6. The second coordinate means that coordinate might, let's say, will have 2 coordinates. One is for x, the other is for y, or one is for a, the other is for b, the way you call them. And for the variable, the first one, so that's a location for our nuclear reactor. So our nuclear reactor is x and y in our definition, but I want to put it like together. So I have x coordinate. So xa will be on 1 dimension, xb is on the other dimension. And u plus and u minus, that's exactly what I did on the blackboard. So that's a positive part, so u plus and u minus. Positive part and negative part. Obviously, both of them are for each term, right? And the second one is that, well, like what I did in the blackboard, that's only for variable x. So we also have to do for y, so that's why I put coordinate here. And theta is a binary variable. And if we check the objective, that's exactly what we wrote on the blackboard. So 1/6 are multiplied by the total distance, right? And when you check the first constraint is that one. So how we define our new variable, like the positive part and negative part? I would say, well, it's defined in a way. So xj is a coordinate from our nuclear reactor. When we subtract the location, the location of the term from our nuclear reactor, so this part on the left-hand side can be positive or negative. It should equal to the definition is plus part minus the minus part. And second one, the second constraint and the third constraint are the 2 constraints we put here, the binary constraints. We basically copy them over there. And that's it for the model. So I want to show you the data file. So location
Data
for
file
big M constraint. So if you check the big M constraint, so what I did here, so instead of using big M as a single number, I define a big M for each term and each coordinate. So if you check that big M, so you say for first term number 1, we have 9 and 6. That comes from the coordinate, right? And for the last term, the number 6, the last one, that term has a coordinate at 10 and 6, right? Obviously, if you build our reactor at 0, on the x-axis, the maximum distance we can achieve is 10. So I have basically I push that m as small as possible. So I can show you why I want to do it. So let's solve the problem. So everything's okay now. Let's solve it.
打死我也不说码农啊！
马桶还是跟这个不一样。
So we get the solution solution, we want to maximize the average distance. We get a solution which is 12, right? Did you get the same number?
Of course not.
No. So let me show you. So what if, whenever I talk about strong formulation, it always comes when we relax that binary constraint. Because you did manually, like solving the branch and bound trick. Remember in one of the exercise, you solved like a 17 linear programming problem in order to achieve an integer solution, right? When we put the binary variable here and echo what one put this in, we send it to the solver, which is called MP here. They first relax that integer, the binary constraints. Then we solve the linear relaxation problem. Then we so sum of the variable fraction. So we start branching. So basically, just for that second, they solve really a series of linear programming problem, right? But this is a really small problem, so you can't really tell how much time we spent. But what if it's a really big problem, right? When it's a really big problem, so I want to show you. So if we don't have these binary constraints, check the solution. Our objective is what? 15.3. Right? Obviously it's true because we are maximizing over something. When you relax the binary constraints, the optimal solution will increase, right? And what the branch and bound did is that basically we start from this 15.3 and we start branching, and finally we achieve 12, right? But it seems not too far away, like 15 to 12 is like only 3. But what if instead of using my customized I,
它的 M 是个 parameter 吗？
是啊，是。
so instead of using like I say let's just use 10, right? So let's use 10. What number shall we get? Can you have a guess about the objective if I solve the model? Sorry?
Same.
Yeah, I think so.
Oh.
Oh shit.
Check the objective. Right now, what number do we have now? 18.65.
What the?
It's bigger. Does it make sense?
不是 binary 的话，它是什么东西？
Because if instead of using like customized some of the, because right now we have to be all equal to 10.
I don't understand if theta isn't binary, then what is its purpose?
Sorry?
When you make theta, like it's no longer a binary variable.
The purpose I want to demonstrate, this is a strong formulation. Because when theta is a binary variable, because you don't solve the problem, the solver solve it for you. But if the problem, and I want to show you, when solver solve it, solver solve the problem. When we have a binary constraint, how does solver solve it?
Yes or no?
No, because why? You remember we learned branch and bound. That's how solver solve it. Solver don't solve directly with the binary constraints because solver can't deal with binary constraint. What solver did is that he first relaxed that binary constraint. He solved the linear relaxation. Then he checked if all the binary variable they are binary or not. Highly likely some of them are not binary, like 0.5. Then he branch on that variable. Then he do it again and again by iteration to iteration until he achieve the solution, right? And this may take ages but right now the computer is very strong, so you can't really tell the difference. But the purpose I want to show you is that basically what solver did is that push from say here from 18 point something to 12. Did a multiple iteration, so it may take a few iterations. But if we start from 15, probably it will be much faster. Right? And you can't really tell the difference here because it's such a small problem. But in reality, when you build up, like say, maybe for the final project, the model is much bigger. If you build it in a really loose formulation, the formulation is not strong enough, it may take ages for the computer to get a solution. You may end up not having a solution. So that's why I keep saying, when you build up a formulation, try your best to get the strongest formulation, a strong formulation. We don't want a loose formulation, right? And here is not that obvious. So instead of having 10,
Oh my god.
if we have 1 million, right? And I want to show you. So you're saying, why do you want to do this? It's binary. Yeah, it's true. Because if you keep the binary constraint here, binary, let's put it back, we solve the problem.
答案哎不一样。啊，
为什么？
为什么不一样？
至少为什么会不一样？应该是一样的，他不知道
对啊，为什么会不一样？
他因为现在找为什么不一样？
是不是改错？
我设的跟他一样，但是当时我就觉得 coordinates 你这样设你怎么加减？结果他就直接这样子 vector 这样加。
So what I want to show you, so when you change that big M, when you change, it doesn't matter what number you change that big M. When you keep the binary constraint, you will always get the same
我也没有
solution.
说那个 coordinate set。
我就 coordinate 所以
You will
设
get a different solution when you do when you solve the linear relaxation.
打死我都想不出来这个。
像瞎眼。气头。哎，这是我算出来的。
What's going on?
真的
Why is changing all the time?
那你看一下为什么会跟你一样？
我推不出来，答案都还10。哎，还不
你为什么要录我？他都讲完了。
不是给我录啊，
哦，给别人录，
有个小伙伴他不来，我找不来录。
真善良。
阿达 ，Are you recording for Christina? Oh, you are. I am too. No, she just wants to hear like what she says. Yeah.
There are two binary constraints. If I have both the big M, it should be 1 million.
But why did you put it like such big numbers when it's supposed to, like, isn't it supposed to be just 10?
No, I want to show. I just show you 10. I already show you 10. I want to show you why I put such a big number. If you keep the binary constraint, when you solve it, check the objective, you still get the optimal solution, right? Because that's the idea. When we have that big M constraints, it's guaranteed you will get optimal solution. But when you remove that binary constraint, look at the objective. How big is that? It's like 2 million, right?
Oh.
That's because the big M is too big. You know, this formulation is not strong enough. But if instead,
很奇怪了。
when we use our customized like that big M, the one we define in the data, which is pretty small, we solve it. The objective is only 15.3. So imagine when you have a really loose formulation, you branch and bound from 2 million to 12, how long will it take? Over like if you have a strong formulation, you are starting from 15.3 to achieve 12. Which one is better? Obviously, it's a strong formulation. So that's what I want to show you.
OK. 吓哭了。
Okay? Are we okay?